Wouldn't it be great if you could use magnetic shielding to achieve a state where magnets repel and no longer attract? As you can see here, a machine could run forever because whenever magnets meet, they repel each other and generate free energy. Just watch this video and you will understand for sure why this great machine is not able to work. We can find devices of this type on the internet in different forms. It is always about using either the magnetic attraction, such in the SMOT, or the magnetic repulsion, as in the magnet gun. In any case, an additional force is always required to either move the moving magnet into or out of the machine. Here we have a difference to the other magnet machines, because we use a trick to prevent magnetic force from working in places where we don't want it. What we are looking at here. Two wheels are fitted with magnets at equal distances from each other. The wheels are rotatably mounted, so that they can freely rotate in exactly one dimension. The wheels are close enough together so that the magnetic fields on the magnets on them can influence each other. There is a magnetic shield between the wheels, a so-called mu metal. The magnets are aligned in such a way that the identical poles always approach each other, for example, the north poles. If the wheels are started in the right direction but with opposite spin and at the same speed, then the magnets just reach each other in such a way at the tip of the mu metal that they only meet when their movement has already diverged from each other. The mu metal prevents the magnets from repelling each other and changing their direction beforehand. The repulsion thus accelerates the magnets but does not slow them down beforehand when they come near each other. Awesome, right? By the way, this video was inspired by Daniel's inventions, and the link to his construction video is in the video description. How is a magnetic shielding supposed to work? In the minds of the most people, this is how it would go. There are two magnets that repel each other, but because the magnetic shield is in between, they are not affected by each other's magnetic field. If we remove the shielding, the magnets repel each other as usual. Oops, you might say, I expect so, but what about the red glass block and the marble ball? In my videos, I usually make the invisible magnetic field visible by representing the magnetic attraction as a deepening and magnetic repulsion as a hill. The stronger the magnetic force, the greater the impact. So let's transfer the magnetic effect of the magnets on the wheel to the gravitational model. For this, we indicate the polarity using the colors red and blue. So when magnets meet, the force they affect each other is represented as a hollow or a hill. The marble ball reacts to this force as in gravity. Here we see magnets that attract each other, the hollow, or repel each other, the hill, without shielding and then are partially covered by a shield. One could now imagine that the position of the shielding has a sharp-edged influence on the position of the force, because the shielding also ends at exactly one position. When the ball of marble rolls sideways, there is a sideway deflection of the magnets themselves. So the magnets slide sideways and don't just move in a straight line in the fastest path to the point of highest attraction or away from the point of highest repulsion. Such a lateral shift cannot be detected in the experiment. The shield only reduces the area of impact and does not specify a direction, only as if the magnet itself was getting smaller. However, magnetic fields always have the property that they expand and want to occupy the entire space around the magnet. This sharp edge, which is shown in the glass block, does not exist, as can be seen in the following illustration. Instead, it is a normal expansion of the magnetic field, only in the portion of the shielding reduced strength of the magnetic field. As expected, the magnetic shielding actually acts on the influence of the magnets on each other, but not in a particular direction, but only as a weakening of their magnetic field. The marble ball does not roll to the side, and therefore there is no lateral displacement of the magnets against each other, just a repulsion. So the shield acts as if the magnet itself is getting smaller, and therefore has less force to act on the other magnet. With the caveat that we only include the total force here and neglect the north and south polarity of each individual magnet. But this cannot create a contradiction here, since only magnetic repulsion is used anyway. So here we can see which forces act when the magnets are guided past the magnetic shield, as with the magnetic motor discussed. The question of why there is a hollow first will be clarified in a moment. Let's optimize and reduce the structure a bit first. If our thesis is correct, we can even simplify the principle of the machine. 2 wheels are used, but this can cause difficulties, because both wheels would have to be designed exactly symmetrically in terms of weight, friction and magnetic force. If these requirements are not met, it can come to a standstill. Now, let's forego a wheel and instead just position a magnet at the position where the mu metal ends. The remaining wheel continues to rotate because, except for a small proportion of the repulsion caused by the magnet moving away from the second wheel, the principle remains the same. Wouldn't it be wonderful if the world worked like this? There was still an open question. Why did the glass block have an hollow when the magnets were shielded from each other? And what prevents the wheel from turning? The principle seems so appropriate. As already indicated, many people think of a magnetic shield as if it neutralizes magnetic fields and has no effect itself. It would be made out of a material that is not itself magnetic. Unfortunately, that is not the case. All materials that are able to shield magnetic fields are themselves magnetic. In principle, they do not have their own magnetic field, but they are attracted by magnets. Thus, the mu metal in the middle between the rotating wheels attracts the magnets on it. Thus, the magnets are attracted on the one hand and repelled on the other. Since these two forces depend exclusively on the strength of the magnets used and not on the shielding material used, attraction and repulsion are again symmetrical, though these balance each other out. For clarity, here is a representation of the magnetic forces transmitted as gravitational forces. All relevant forces are shown here. The individual forces applied to the magnets on the left and right are represented by the glass blocks on the left and right. The forces acting together on the magnets are represented through the glass block at the top, and the forces applied to the magnetic shield at the bottom right of the shield. With this knowledge in the background, you now form your own opinion. What do we learn from this? This system looks like it is capable of creating a permanent imbalance. Unfortunately, the magnets not only repel each other, but at the same time attract the mu metal, which is used as a magnetic shielding, just as strongly, so that a symmetry is created in the end. It is again the symmetry that dominates our world and destroys our dreams. When the wheels are pushed, they slow down and eventually rock out, because there is no free energy inside. I hope I was able to shed some light on the magical world of perpetual magnet motors. If you liked this video, please give me a like and subscribe to my channel if you dare. Thanks for watching, have fun!